All right. From yesterday, okay, we learned your new formula. Forces are measured in what? Okay, they're measured in newtons. You see a mass in kilograms, and you have an acceleration in meters per second squared. I thought I had these chairs stacked up over here. Okay.
How do we find force again?
Well, we're going to discuss that. That's why we're going over it. Okay. Just like every other time, you've read the problem. What should the next thing you do? Set it up or write down what we know. So let's go over and we'll do this bottom one first.
Mass times acceleration.
Yes, we wrote that down. You didn't write it down. It was supplied to you yesterday. Okay? All right. Do you want our help or not? Okay. Well then, any staff member here, okay, we got a job to do. We're just trying to do it. Okay? We're trying to help you out so that once you leave these doors for the last time as a student, and yes, I understand you're going to return as, what would you say, an alumni or an alumnist. That means you've graduated, okay, and come back as a person who's graduated. But before you leave for that last time, we're trying to make sure that you are prepared to be ready for that next step you take in your career, whatever it is. Okay, so with this bottom one, you've read the problem. What is measured in kilograms?
Mass.
Okay, so mass equals 8.6 kilograms. What else do we know in the problem?
Acceleration.
Okay, now it says it's moving at this. Since it's measured in meters per second squared, that makes it an acceleration. And then what is the question asking for? Right here, the force. So now you've got this wrote down where we see it in one spot. What does the formula tell you to do? Okay, so in order to solve this, how are we going to complete it?
8.6 times 11.65, and it's 100.19.
100. And that's measured in newtons. Or you could label it as a mass per meter per second squared. Same thing. M dash M over S squared. You can make it a derived unit. Oh, yes, kg, sorry. But it means mass. So, right. So it would be kg dash meter over second squared. But it's a derived unit. It's just much easier to say newtons as opposed to kilograms per meter per second squared. It's just a lot easier to just say newtons. Okay? Pretty straightforward with this, we hope. Agreed? Can we erase this? Okay. Okay. This top one is maybe a little more difficult. Okay. So with that, let's go through our variables. What do we know in the problem?
Distance is 47. Your mass.
So when you said this, that's correct, but how do we know that that's a distance? It's measured in meters. Or you could say it's starting point. What else do we know?
Mass is 110.
What else do we know?
Time is 6.2. Initial velocity is 0.
That's important to know. Why is that important to know?
To get our acceleration.
Right.
But first you need to find that final velocity.
Okay. We don't know that, do we? We don't know the force, right?
Nope.
Saying how much force was involved in these 6.2 seconds. But some of you are already ahead of this and saying we need to find the final velocity. So then once you find that, then we need to find what after that. In other words, we don't know this one, and then we don't know that. Okay? So that is why we want you to write down this information.
So we want to do distance over time.
That is correct, because any distance over a time will give you what? They give you velocity. In this case, it will be the final velocity. So in that case, how would we solve for your final velocity?
47 divided by 6.
Okay, 47 divided by 6.2.
And it's 7.58.
Meters per second. Now, I make fun of the chemistry students with this too. Okay. With this, what you might do is you get to this point and you get disrupted with something. Distracted, I don't know. But what would happen if you were to do that? You come back, oh, this must be, yeah, then you're putting that in for an acceleration. Okay? You might get a similar answer, but you're not going to get the correct one. Okay? So let's see how close this velocity is to the acceleration, because it's not probably the same answer. Okay? So with that, leave that as a velocity. So in our next step,
It's final
your
velocity minus initial velocity over time.
we don't need to put this in parentheses, do we? Why not? Because anytime you take that away from 0, you're just going to get the same answer.
And then over 6.2, and it equals 1.22.
That's not very fast, okay, in case you're wondering. At least I don't believe so. But you're still solving this the same way. Is this going to be an accurate real-life application? No. Go where the numbers lead you, okay? So now we've got this variable. We solve for that one. Now we can do your force, okay? 1.22 times 110, and we get what?
134.2.
Newtons, right? That's how you're going to solve for that. Of course you're going to do that, because you wouldn't do it any other way, correct? I'll just make fun of you if you don't. It doesn't have to be a capital N, but I'll just laugh at you. But no, just make it a capital N. Okay. So now, how many of you from the first, let's say, 4 or 5 days, the problems that we were solving were pretty straightforward. You're just looking for a velocity, just distance over time. Or if you had a velocity and a distance, you had to see what the time was. Or if you had the velocity and you had the time, you just had to see once what the distance was. Okay? From that point to here, can we now understand why this is so important? Okay? How many of you would agree that it makes it a lot simpler when you have this information here rather than looking up in the problem? I think that anyone would say that that makes a little more sense than anything else. All right. So we were going to talk about friction today, but a lot of you are gone tomorrow. To keep this more or simpler, if you are here tomorrow, your hand up. So I just have an idea. Okay? All right. Makes sense. All right. So with that, we will stop there. We'll continue with this, what was called, sports athletics and the different type of sports, footballs, soccer balls. Okay? Now, how many of you... we don't need to talk about that now. We'll catch up to you next time.